Consider a function f of x, which maps the interval ab to the real numbers. I can draw an example of such a continuous curve here, with x plotted against y equals f of x. What would happen if we were to rotate this curve 2 pi radians around the x-axis? With the x and y axes as before, I draw the z-axis pointing into the page, and so we have a three-dimensional set of axes. After rotating our curve, we'll have a circularly symmetric object, like this. What we have here is a 3D shape, called the surface of revolution. How do we find the volume of the shape enclosed by this surface? If we consider a fixed value of x, we know our function will take a value, f of x, which is rotated around the x-axis. And so in the yz plane, we have a circle of radius f of x. This circle has an area, a of x equals pi times the radius, f of x squared. And so to find the volume of the solid, we integrate these areas over all values of x, i.e. the integral from a to b of a of x with respect to x. And so our volume v equals the integral of a to b with respect to x of pi times f of x squared. For an example, consider the function f of x equals x multiplied by x minus a, where a is a positive real number. We wish to minimize the volume of revolution of f of x when we take x to lie in the interval 0 to 4. By our formula for the volume, we have v equals pi times the integral from 0 to 4 of x squared multiplied by x minus a squared. We wish to minimize this integral over all a. Solving dv by dA equals 0 will give us the value of a for which this is minimized. To find dv by dA, we can take the derivative of both sides of our equation. Since pi is a constant, we can take it out of the derivative. Now we use Leibniz's integral rule to put this derivative inside the integral. We have now pi multiplied by the integral from 0 to 4 of the partial derivative with respect to a of x squared times x minus a squared. The only term involving a is x minus a squared, and its derivative is minus 2 times x minus a. And so we have 2 pi multiplied by the integral from 0 to 4 of x squared multiplied by a minus x. By using the power rule for integration, this equals 2 pi multiplied by a third x squared multiplied by a minus a quarter x to the 4 evaluated at x equals 4 and x equals 0. Since both terms involve powers of x equals 0 does not contribute to the value of this integral. And so we have 2 pi multiplied by 4 cubed, 64, over 3 times a, minus 4 to the 4 over 4, 64. Taking out the factor of 64, we have 128 pi multiplied by a third a minus 1. Now set this equal to 0, and we see that a third a minus 1 equals 0. And so we have a equals 3. This tells us f of x equals x multiplied by x minus 3 gives us the minimum value of the volume of revolution over x from 0 to 4. The surface of revolution looks a little like this. We can calculate our volume of revolution too, which turns out to be 64 pi over 5. Thank you for watching and stay subscribed for more.